All right, Algebra 2. This is part 2, page 2. So I'm basically working on the other side of your worksheet. So on this problem, we're still simplifying like we did in the previous problems up here. So now we're going to be simplifying this expression. Excuse me. Now to simplify this expression, the first thing you need to do is check, okay, well, what kind of operation do we have here? Well, I have addition. So in order to add two rationals, I need to have the same denominators. And it looks like we have that. We have two denominators that are the same. So all we have to do is then add the numerator together. So now we have x minus 2 plus 4x. And I'll tell you why I put that in parentheses here in a second. So now I'm going to just write the denominator. Remember, we don't add the denominator. We only add the numerator, just like we would if it was a fraction. So if I had 1 over 3 plus 2 over 3, well, that's not equal to 3 over 6. That's just equal to 3 over 3, because we only add the numerator. Okay? Same thing applies here. Now, the reason I put parentheses around the binomial here and the term here is because sometimes we might have a negative here. And if we have a negative, we need to make sure we distribute that one, like down here in number 13. But just as good practice, put parentheses around it for adding and subtracting. Now, this addition is not going to do anything, so we can just take those parentheses down, and it's just x minus 2 plus 4x all over x squared minus 5x plus 4. And then we'll have the terms on the top that we can combine. And let's combine the ones that are like each other. So we have x and 4x. And then minus 2, because that's all that's left there. And then rewrite the denominator. And now we want to see if maybe we can cancel out some factors. So let's go ahead and factor out the bottom, or the denominator. Now, we would want to try to factor out both the numerator and the denominator. But just looking at the numerator now, I couldn't do anything with that. There's no common factors between 5x and negative 2. So on the bottom, let's factor that out. I have x and x. And then I would have 4 here, 1 here. In order for them to add up to negative 5, they'll both have to be negative. And just looking at it, I can't do anything with that. There's nothing I can cancel out. So I'll just leave my answer like that. Okay? And that would be it. And remember, we always just leave the denominators factored. Okay? Don't multiply them back. Okay? So let's go to number 12. Okay, so now, this one, we've got addition. So if we've got addition, again, we need to make sure that our denominators are the same. And it looks like they are. And then we can just add our numerators to the top. And again, like I did before, put in parentheses just in case. And it's plus 4k plus 3 plus k plus 1. And both of these, and all over the same denominator. 12k squared minus 4k. Now there's a plus between these two binomials on top, so that we can just take the parentheses down, because that plus isn't going to change anything. Now, like before, add our numerator, add the like terms. So I have 4k and k, that makes 5k. And then I've got 3 and 1, so that'll make 4. And I've got 12k squared minus 4k. And again, just to see if we can simplify it, let's factor out the denominator. and the numerator. Well, looking at the numerator, there's no common terms there, so we couldn't do anything further. But let's see if we can get something to cancel out here. So on the denominator, it looks like our common denominator would be a 4, and we could also take out a k from both. So then on the left, we'd be left with 3 times k minus 1. And looking at it, there's nothing we can cancel out, so we would just leave it like that. Okay, now let's move on to number 13. Now here, we've got a different situation. What's different is, one, we have subtraction, and if you look at our denominators, they're different. So if they're different, we can't just go right ahead and start combining or adding them, or subtracting them in this case. We have to make the denominators the same and find a common denominator. So in order to do that, when they're different like this, all I'm going to do is multiply. I need to find basically a least common denominator, an LCD, or least common multiple between 3 and r minus 4. Now if you got a binomial like this, you simply just want to multiply this denominator times the denominator on the left, and then this denominator times the opposite denominator. And remember, if we multiply the bottom, we also have to multiply the top. Okay. So now, let's just go ahead and combine these two. So now it's r minus 4 times 3r. So we'll distribute that 3r. And we'll get 3r squared minus 12r all over 3 times r minus 4. And don't multiply the denominator. Remember that. Just leave it factored. And then over here, 2 times 3 is 6. And notice I haven't combined the two rationals yet. I'm still just multiplying the numerators. And then the same denominator. Okay, now let's move on to number 14 over here. Try to get it focused in there. Alright, so here's another case. Subtraction and different denominators. So, first we need to find a common denominator. In order to do that, multiply this denominator by the opposite one, or the other denominator, and then multiply this denominator by the denominator on the right, just like we did in the last problem. And remember, if we multiply the bottom, we also got to do the top. Okay, so now, let's turn my black. Okay, now we have to multiply the numerators. Okay, so it looks like we've got two binomials here, so we'll have to FOIL on the top there. So I have n squared, and then 3 plus 4 is 7, so 7n, plus 4 times 3 is 12, and all over that same denominator, remember, don't multiply the denominator, leave it factored, minus this 2n times n plus 1, so let's distribute that 2n. So now we have 2n squared plus 2n all over that same denominator. Now we can combine the tops, or add the tops together. And again, remember, use parentheses, and you're going to see why I'd use parentheses right now. Okay, so now parentheses over here. Oops, that's a plus. All over that same denominator. Now if you notice, we're separated by subtraction. Saw this mistake a lot on the test as well. If it's separated by subtraction, then that means you need to distribute that negative to the expression to the right, to that binomial. Okay, it changes the signs. You need to make sure you account for that. So let's rewrite it with that change. Okay, so now I'm just going to rewrite the left. I can take the parentheses away on the right. I mean the left side, because it does, nothing changes. And now I'm going to have negative 2n squared minus 2n, because I distributed that negative there over here on the left. Now, with this, I can combine like terms. So let's combine some terms here. So I've got an n squared here, an n squared here. So that will combine to be negative n squared. And then I've got an n here, an n term here. So that's 7 minus 2, which is positive 5n. And then I've got just a 12, so plus 12. All over n plus 4 times n plus 1. Okay. Now let's see. I could try to factor this out, this numerator. So let's try that out. In order to factor that, I'm actually going to have to get rid of this negative. Because when you factor, you can't have a negative leading coefficient. So what I'll do is take out that negative. So now I'll just have negative 1 times positive n squared. And then since we're taking out a negative, it changes the sign. So now I have minus 5n and minus 12. And you know what? This might not factor, but I need to try. I need to see if it can. So over here on the side, pick a new color so you show we're just doing this here off to the side. So now I'm going to take this off to the side and see if I can factor it. And if I can't, I'm just going to leave it like it is. Okay, so I'll have n here and here. And is there a number that I can multiply to 12 but also adds to 5? Well, let's see. 6 and 2. No, that won't work. 3 and 4. No, that won't work. The only other option is 12 and 1. So nope, I can't do anything with that. So I can just leave it like that. And if you figure out that there's nothing else you can do, you could also just leave it in this form. Okay? So either one is acceptable. Alright? Okay, well, let's move on to solving equations. Now, before we were simplifying. So we ended up with an expression, like we did up here. Like this expression here, or this one, the one we just did, this expression here. That's not an answer. That's not a solution. Here, I need to end up with a solution. So we're actually going to end with an actual answer. X equals some number. All right? So, before we actually start, before you start any of these problems, you need to remember, look at the instructions, remember to check for extraneous solutions, or what we also call excluded values. Point of discontinuity, if you remember when we were graphing. Okay, it's all the same. Values of x that cause our denominators to be undefined. Okay, that's what we need to check for first. Because in the end, we find that our x is equal to one of those excluded values, then that x value cannot be one of the answers because it'll make our equation undefined. Okay, so let's go ahead and find those extraneous values or excluded values here. So I have to think, what number do I plug in to these x's to make them 0? Well, 0. I just would plug in 0. And there's nothing else I could plug in, so then that's it for the excluded values. Now what we want to do, as Mr. Kershaw and I have explained to you, is make it easier on yourself when you're multiplying these. Spread it, rewrite the expression, or the equation, by spreading it out. You will make a lot less errors if you spread it out first before you begin your work. I know you guys like to jump right to it. What's the fastest way I can get there? But you'll make less errors if you just spread it out. Okay? You have time. And then you'll be happier in the end because you'll be like, oh, I got it. Sweet. All right, so let's start with this number over here on the left. Now, what we want to do is cancel out these denominators because it's a lot easier to work with and solve for x if we can just cancel them out. So, in order to cancel out this term here on the left, this rational, I need to multiply times x and x. Because, if I expand this out here on the bottom of the denominator, this is just x times x. So that will cancel out that x. So let's apply that over here too. X times x and x times x. Because remember, if I multiply one term, I have to multiply all of them. Let's make sure that that cancels out all of them. So then this one, that will cancel out 1x here, but that doesn't cancel out the 6. So it looks like I'm also going to have to multiply 6 on all of these. so I can cancel out that 6. And then let's check to see if that cancels out the rest. So I know that the first one will cancel out. I know that this one will cancel out now since I'm also multiplying a 6. But how about this one here on the right? Well, I know that 6 over 2 should cancel out our denominator there. Okay, so we're good. So that'll work. So now, let's go ahead and cancel. So now I can cancel x, 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 and x. Okay, remember, we just factored that, so that's not there. So now all I have there is a 1 and a 6. And here, I can cancel out 1x and 1 6, and then I have an x and a 1 there. And then here, this is also 2 times x times x. So I can cancel out an x here, here, and then this 2 will cancel out when I do 6 divided by 2, and then I'm left with a 3, okay, on the top. So I'll have a 1 and a 3. So now let's rewrite that. So now over here, this first term, it's 1 and a 6, so that'll just be 6. I want green, black. So just be a 6. And then here, we cancel out everything but a 1 and an x. So it's just 1 times x. And then over here, we've got a 1 and a 3. So it's just plus 3. And doesn't that look like a whole lot easier to work with? Sure does. So now, isolate x. Let's subtract 3 from both sides. Get rid of it from this side. And then now we'll have, I'll just switch it around. You can do that. X equals 3. And make sure that that 3 is not one of your excluded values that you found in the beginning. And it's not an excluded value. So that would work. There's your answer there. Okay, now the next one. Okay, so now this one, first thing you want to do, find your extraneous value. And in order to find that in this one, we're going to have to factor here. So let's go ahead and factor out this trinomial to see what extraneous values we can get. So now I have x here, and what two numbers multiply to 30 but would add negative 30 but add to negative 1? Well, let's see, 6 and 5 would work. And in order to be negative 1, that means my bigger number would have to be negative, and my other smaller number would have to be positive. Okay, so now let's look and see what extraneous values or excluded values we need to account for here. So the 1, there's obviously no denominator there, so we don't need to look at that one. This x plus 5, well, if I plugged in negative 5 there, that would make it 0, so we don't want negative 5. And then looking at this trinomial factored out here, negative 5 would also make that 0, so we already got that one. And then over here for the x minus 6, 6 would make that 0. So those two values could make our denominator 0. So we want to make sure that we avoid those solutions in the end. All right, so now let's go ahead and do the rest of the work. Remember, expand it out, or say, give yourself some space. Rewrite the problem. And I already factored out this last expression, so I'm just going to leave it factored. X plus 5 times x minus 6. Okay. Now I need to figure out, what do I multiply to get rid of these denominators? Let's start with this one here. Okay, so I would have to multiply x plus 5 to get rid of this denominator. So I'll do the same here. And the same to the 1 over here. Because remember, multiply all of them. That'll get rid of this denominator. And it'll get rid of this factor over in this denominator, but we also have x minus 6 here. So that means I need to also multiply x minus 6. Okay, and we do that to all of them. And you see why I spread it out, because it's starting to get kind of tight in there, because there's all these different numbers I'm multiplying, or binomials. So we start with the first one. Well, there's nothing going to cancel out there, because there's no denominator. Here, we cancel out x plus 5, x plus 5. On the last one, we can cancel out x plus 5, x plus 5, x minus 6, and x minus 6. So that means here we're left with a 1. The middle, or the second rational expression. We're left with x plus 3 and x minus 6. And over here we have the x plus 5 and the x minus 6. So let's go ahead and multiply all those out. Okay, so over here on the left, x plus 5 times x minus 6. We'll just FOIL, so x squared. And then I know that that x plus 5 times x minus 6 is already that original trinomial I had in the beginning. So it's x squared minus x minus 30. And now I've got x plus 3 times x minus 6. Well, that's x squared. And then let's see, negative 6 plus 3 will be minus 3x. And then 3 times negative 6 is negative 18. And then it's plus, make sure you pay attention to whatever that sign is, because if it's not plus, then I need to distribute that negative, okay? And then I'm only left with a 1 over here, so on this last one. So that's it, right there. Okay, so let's go ahead and combine like terms if we can. On this left side I can't. On this right side I have a 1. Oops. Sorry. So now it's negative 18 plus 1, which would be negative 17. And now I have some x squareds in here. Well, what I'm going to do first is, let's see. If I have a squared term, I might have to factor at the end. So let's go ahead and move that to the left. And I'm only going to start with that first, just that one. So let's subtract that from both sides. And if you notice, they cancel out on both sides. So if that's the case, then I have to approach this a little different. Because if I did have x squared, I'd move everything to the left and I would factor it out. And then I'd find my solutions. But here, they both cancel out. So now let's isolate x on the left and then bring all the other numbers to the right. So now, let's rewrite this so you guys can see it. So now I have negative x minus 30 equals negative 3x minus 17. Okay. Now, I want x on the left and my numbers on the right. So that means I need to add 30 here and then add 3x here. Okay, so that means add 3x here and add 30 over here as well. Okay, so those cancel out and then add up the rest. So now let's move it over here. So now I'm going to have negative x plus 3. Well, that would be 2x. And then equals negative 17 plus 30. Well, negative 17 plus 30 would be 13. And then our last step would be divide by that term that's in that coefficient in front of the x. And so I end up with x equals 13 over 2. And go back to your extraneous values over here on the left. Make sure it's not one of those, and it sure isn't. So then that is our solution. X equals 13 over 2. Okay, the next one. Now this one, again, when you want to see if we can factor at the bottom, it looks like we don't have to factor these because there's no common, there's no GCF, and they're not trinomial, so we can't reverse FOIL. So let's just go ahead and find our extraneous value. To plug in, what do we need to plug in here? Well, we'd actually have to take that off to the side here. What would make it equal 0? So let's set it equal to 0. Add 1 to both sides. And then we have 3n equals 1. And then divide both sides by 3. N equals 1. Then that would mean I would have to plug in a 1 over 3. Okay, so 1 over 3. An easy way to see that is, well, the number on the right is a 1. The number on the left is a 3. So I could just put the 1 over 3. And remember, x is a liar, so I would need to make it a positive, because then that would make this 3 cancel out. Okay, so you could either do it like this, or you could just recognize if I put a 1/3 in there, that I'm left with 1. Okay, and then for these other ones, I would plug in a 3 to make them 0. Okay, that's an answer. Okay, last problem. Okay, so now I want to find some extraneous values first. In order to do that, I need to factor out one of these denominators. Okay, so this will be x, and let's see, 4 and 2. multiply to 8, can add to 6 if they're both negative. Okay, now I want to find extraneous values, or excluded values. So for this first denominator, I would have to plug in 2. The second one, I'd have to plug in 4. And is there any others? No, well this is just x minus 2 and x minus 4. So they're the same. Alright, so we just have 2 and 4 as our extraneous values. So now, let's rewrite, oops, wrong button. Let's go with, where'd my blacks go? There they are. Okay, now let's rewrite the problem. Kind of widen things out so it's easier to work with. 1 over x minus 4, and then 2 over, remember, leave it factored out once you've factored it, just so that we can try to cancel out some of these factors. Alright, now, what do I multiply times this first expression in order to eliminate that denominator? Well, x minus 2, so do the same to all of them. And then the second expression, I would also have to multiply x minus 4, so I do that to all of them. And then going to the last expression here on the other side of the equal sign, sorry, there you go. Looks like I'm good to go, because I have x minus 2 and x minus 4, those will cancel out. So now let's go ahead and do that. So here on the left, x minus 2 will cancel out, and then I'm left with x and x minus 4, so make sure you distribute that. And here, x minus 4, so I'm just have 1 times x minus 2. And then here, both denominators, both factors on the bottom will cancel out. So all I have is 2. So now, on the left here, it's x times x minus 4, so distribute that. X squared, x times x is x squared, x times 4, negative 4x, negative 4 is negative 4x, plus, and we have a plus here in the middle, 1 times x minus 2, well that's just x minus 2, equals 2. And that's all we have left over there. Now let's see if we can combine some like terms. We have 2 here. Okay, oh, no, we don't want the equal sign there. Okay, so now we have negative 4x plus 3, which is, negative 4x plus x, which is negative 3x minus 2, equals 2. And then our last step here, we want to move everything to the left because I have an x squared term here on the left. So let's subtract 2 here. Okay. And now let's move it up to over here to the right. So those cancel out. And I'm going to move everything over this way. There's my black. Okay. So now I have x. Oops. I want to choose my black. There we go. So now I have x squared minus 3x, and then negative 2 minus 2 is negative 4 equals 0. And the reason I moved everything to the left is because I have an x squared term, and that tells me that I'm probably going to have to factor at the end, so I want everything on the left side. So now I want to factor this so I can figure out what's going to make this equation true. What do I have to plug in to make this equal 0, this 0 that I have on the right? So I'll here have x here, and what two numbers can multiply to 4 and add to negative 3? Well, I think 4 and 1 will work. And I'll have to have negative 4 and positive 1 in order for that to be negative. So now I have to say, what do I plug in here and here to make this equal 0? Well, for the first one, I'd have to plug in negative 1, and the second one, I would have to plug in positive 4. Now, key step here. This is why we do the excluded value. Look back at your extraneous values. Is the negative 1 one of the excluded values? Nope, so that one's good. Is the 4 an excluded value? Yes, it is. So I cannot have 4 as one of my solutions. So the only solution is x equals negative 1. Okay, and that's it.